You are looking at trees. Normal trees here on Earth. We don't usually see them this way because our eyes can see just a small sliver of the light that hits our planet. You're seeing plants as they appear outside of the visible range. Just beyond the red end of the spectrum, thanks to a special camera that can see near infrared light. This hidden world of color, invisible to us, holds clues about why trees and other plants look the way they do here at home, and even what they could look like on other planets. Hey smart people, Joe here. Alien trees. We're going there with science. The universe is a big place to look for anything, but telescopes and technology are getting better in big ways all the time. We live at a time where it's actually possible we could detect signs of life on a faraway planet orbiting another star in our lifetime. It's pretty awesome. We just have to know what to look for. Life requires energy. It's just a rule. And the ultimate source of energy for basically all life on Earth is the sun. Even though I might be powered by tacos and coffee, ultimately all the energy in those things can be traced back to living things that harness energy from light. Plants. Photosynthesis takes advantage of the fact that there's basically a free source of energy just raining down from the sky. So it's pretty likely that living things on other planets would also harvest light from their star to power life too. The tricky part is, you need a way to catch it. Here on Earth, deep inside green leaves, that happens in a place called the chloroplast, where special pigment molecules can actually catch light to power photosynthesis. But plants on Earth don't use just any light. It turns out they're kind of picky, and that pickiness explains why they're green and why they look like this when we view them into the infrared part of the spectrum. I hope you like a little physics in your biology. Here's the spectrum of electromagnetic radiation we can see. It's just a narrow sliver of what's out there in the universe. The simple answer to why are plants green is that they bounce green back to our eyes. Whatever light a plant doesn't use is what gives them their color. Green light is the light plants least absorb and the light they most reflect. But here's the weird part. We orbit a star that gives off a ton of green light. So why are plants reflecting that light away instead of using it? In fact, why don't plants use all the colors of light available? Why aren't they black? Because billions of years of evolution have taught plants to work smarter, not harder when it comes to collecting light. Let's take a minute to talk about photosynthesis. It is a really complex process, but it boils down to this. Inside plant cells, there's special photon-catching pigments that harness energy from light. They use that energy to rip apart water molecules and steal their electrons, which releases oxygen for us to breathe. Then they take those electrons and use them to build sugar molecules from carbon dioxide. Photons are the basic units of light, but not all photons are created equal. They carry different energies. Down in the bluer end of the spectrum, into the ultraviolet and beyond, a photon carries more energy. In the redder end of the spectrum and beyond, photons carry less energy. So a photon in the ultraviolet is like a fully charged battery, while a red photon is a partly charged battery. Now, it takes a very specific amount of energy to split water during photosynthesis and get its electrons. If a plant plugs in a UV photon, it can get enough energy, but can also overload and damage the plant. And on the other side, if we plug in a whole bunch of infrared photons, we don't get enough energy to do anything, and we just end up overheating the plant. So green plants have figured out a sweet spot. They have light absorbers best tuned to red light and blue light. Red light isn't very strong in terms of energy, but there's a lot of it around, so plants can buy in bulk and make up the difference. And blue light still has more energy than they need, but plants can actually grab blue photons and tune down their energy to a safe level, just like how transformers step down voltage from high energy power lines to a safe level in your house. Beyond the blue end, plants actually manufacture molecular sunscreen to absorb all those dangerous UV rays. And beyond the red into the near infrared, plants reflect basically all that light away so they don't overheat. which is why they look the way they do on that special camera, which is modified to see this near infrared light, which is normally invisible to us. But we still haven't really answered why no green. Green plants weren't the first type of photosynthesis to evolve on Earth. Before green plants and before their ancestors, the cyanobacteria, another family of photosynthesizers existed, purple sulfur bacteria. Earth's early oceans were probably full of them. These guys used a purple pigment which does absorb green light and reflects blue and red, basically the opposite of green plants. When the first cyanobacteria appeared, these purple sulfur bacteria were using up all the available green wavelengths. So instead of competing with them for these photons, the ancestors of today's plants took advantage of the leftover wavelengths that weren't being used, the red and blue ones. Green photosynthesizers gradually took over the purple ones and eventually became plants and trees. All of this together, the mix of wavelengths of light given off by our star and the wavelengths of light absorbed and reflected by the plants that cover our planet, gives us a sort of fingerprint of what life looks like from space. And speaking of space, I did promise you alien trees. We can use this same science to think about what a plant on another planet might look like. Now remember, all life anywhere requires energy, and it's pretty likely that living things on other planets would harvest light from their star to power life the same way plants do here. Plants adapt to what light is available, and the type of light that hits a planet is determined by two things: the kind of star that it orbits and what's in a planet's atmosphere. Light is filtered by gases in the atmosphere. In our own atmosphere, things like oxygen, water vapor, and ozone block certain wavelengths of light. Only some stars live long enough to allow for the evolution of life. F-type stars are big and hot. They give off tons of blue and ultraviolet photons, which could mean plant-like organisms on those planets need built-in sunscreen to reflect away that high-energy light. Those molecules would give plants there a blue color. Or maybe they'll have evolved a way to harness those high energy rays and reflect green and red. To our eyes, those plants would look yellow. K and M-type stars, on the other hand, are dimmer and cooler than our G-type star, the sun. The planets around those stars might receive just half the energy that we do here on Earth, and most of the available photons would be in the near infrared. Those wavelengths don't carry much energy, so plant life there may need to absorb lots of different wavelengths to have a better chance of catching enough photons to survive. They may reflect basically no light. They'd look really dark, maybe even black to our eyes. It's pretty cool to think that someday soon we'll have telescopes capable of seeing the light reflecting off distant planets orbiting far-off stars. And those tiny specks of light might hold clues in their unique mixtures of wavelengths that say, you know, maybe there's something interesting going on there. Something like life. But for now, we should remember that Earth is the only place where we know life exists for sure. So we need to make sure we take good care of the green stuff and maybe even plant a bit more to be safe. Because without them, there would be no us. Stay curious. First of all, a huge thank you to everyone who supports the show on Patreon. Patrons get a bunch of cool perks. You might even see a behind the scenes video about how we got all the cool near infrared tree shots that you saw. If you'd like to join our community, there is a link at the end or down in the description. You can even join the ranks of these Galaxy Brain patrons. This video was so fun to make. I got this camera converted so it picks up near infrared light a while back, and I've been taking on a few trips whenever I thought I was gonna see some cool trees, and it is just amazing what you can learn by looking at nature literally through a different lens. NASA actually uses near infrared cameras like this on satellites to monitor the health of forests and trees down here on Earth. And what we've learned from studying Earth's forests is not great news. From the dawn of human civilization to today, humans have cut down around half of all trees on Earth. We've lost 1/5 of the Amazon rainforest in the last 50 years. And for every minute that you just spent watching this video, we lost another 30 soccer fields or so worth of forest. We need to plant more trees, like a lot of them. And a bunch of your favorite YouTubers are working to make that happen in a big way, like a really big way. Right now, you can check out this video from Mark Rober to learn more. Seriously, feel free to leave my channel and go check it out. Sorry, that was pretty acorny. Okay, that was pineful. I know you're sick of more puns. Just trying to spruce up the planet together.